Alright, so your third and final type that we're going to talk about of ways that we can make the nucleus stable is called gamma radiation. So gamma radiation, I think, will be your guys' favorite one. It's pretty short notes, so stay with me. So gamma radiation actually has the highest penetrating power. So before we talked about alpha particles can't even go through paper. Beta particles can go through paper but get stopped by metals. And then gamma, which that's a symbol for gamma, it can go through paper and metals and some things, even like other types of stronger metals like lead. It can go through. So it's really high penetrating power. It can be really dangerous, things like that. Gamma radiation is, what they talk about the Hulk, how he was created and stuff was by gamma radiation, so that's interesting. One thing about gamma radiation is that it is not a particle. So all the other things we talked about have been particles that actually come out. Alpha is our helium nucleus, beta is a high energy electron, but gamma is actually just waves, so it's not a particle. So since it's not a particle or anything, it has no charge. So now let's do an example really fast. Like I said, these ones are pretty easy. So for gamma radiation, we're going to start off with this. So remember to write this down, especially because this is what the harder part is. So we're going to have iodine, and it has a mass of 125, and then it's going to undergo, a change, a chemical change, some gamma radiation. And this is a particle, or what we get out of gamma radiation is this. So like before with alpha, we got out the helium nucleus. With beta, we got out that high energy electron. Gamma, this is what we get out. And so we need to figure out what the second thing is that we're going to have. So again, like the other ones, we just subtract across. We look, this is 125 and this is 0. So we're going to have a mass still of 125. So if we have 53 protons and we're going to take away 0, we're going to still have 53 protons. So if we look up at our periodic table and we find 53, we'll see that 53 is still I. So we're still going to have the same atom, the same element that we started off with. So an important note to make in your notes, I'd probably star this, maybe highlight it, write it in a different color, is that gamma radiation does not affect mass or atomic number. Remember, atomic number is just our number of protons. So our number of protons or atomic mass is not going to change. So it's really easy when you do gamma because the same thing you started with and the thing you end with are basically the same because this gamma particle has no mass and or the gamma wave, I guess, has no mass or no change in the atomic number. So I'm just going to go over, since we have a little bit of time left on this video, without making it too long, I'm going to go over one of your homework problems. Okay, so the first page is pretty self-explanatory. The second page, it says that, number 7 it says that you're going to have alpha decay of radon 198. So again, remember this 198, this is your mass, and this tells you your element. So to set up this problem, you go to your periodic table and you find radon. That's your first step. So go to your periodic table, we're going to find radon. So you have to look at these tiny, at the names on them. So like that one's manganese. Radon is going to be down in this corner over here. He says radon. So if we look at radon, we can see that radon is Rn and it has an atomic number of 86. So Rn and 86, we need to remember those. So to start off our equation, we're going to have Rn for radon, and it has a mass of 198. We have to get that one from our problem. Don't get it from the periodic table, from the problem. And then I think it had an 86. Let's go up and double check that really fast. Yeah, so we have 86 protons. So 86. Okay, then it says that it's going to go through alpha decay. So we do our arrow, and then we do alpha. So remember, alpha decay is our helium nucleus, so it's 4,2He. So that's what we're losing, 4,2He. That particle is flying off, and so we have to figure out what our element is now. if we happen to helium nucleus leave or have alpha decay happen. So remember, we take our 198, we're losing 4, so we have 194, and then we have 86, and we have 2 that go away, so we have 84 left. So if we have 194, and if we have 84, we can just go back and look up at our periodic table at 194 and 84. So 84, we can see that it's right here, see 84, so it's PO. So this is PO. So that's how you do some of those ones on the back page. The last 2 ones are just asking for the element. So it says if you look at number 12, it says if rhenium 189 undergoes alpha decay, what element is the product? So again, you have to look for, it says rhenium 189 goes with alpha decay, what is the product? So again, you're going to go find this on your periodic table, and then you're going to use this as your mass, and then you're going to have it go through alpha decay, and then you're going to get your final product. So this one you need to make sure that you tell me what the element is. You can write out this whole equation if you want for those last ones, but the main thing that you're looking for is this final element for those last few. So let me know if you have any questions on your homework. I know that it's kind of hard doing distance and stuff, so I appreciate your guys' work to try to figure it out by yourself. Hopefully this video is helpful. Please let me know if you need any help on anything or if you need me to explain something differently. And once you're done with that worksheet, you don't have any quiz or anything this week, so that is your very last thing. So you guys can have a good, long, nice weekend. Anyways, good luck, and let me know if you need any